Hi, all. Thank you so much for joining us. This is our second activity of day 2 for this virtual workshop, and we have a series of short talks from some Chilean scientists. Our first speaker is Diego Rios. Diego Rios works at the Observatorio Volcanológico de los Andes del Sur, OVDAS, where he is responsible for maintaining technological platforms. His roles include managing physical and virtual servers essential for volcanic monitoring in Chile. So without further ado, I will let Diego Rios take the mic, and thank you again. The chat and the Q&A feature will be on the entire time, so if you have questions, please feel free to use them and we will answer them at the end. Diego, the floor is yours.
Thank you. Good morning. Thank you to the organizing team for inviting me to this webinar. I am Diego Rios from the Chilean Volcano Observatory. And today I'm going to talk you about RNVV Multiparametric Database. Look at the current state. Volcanic monitoring in Chile is carried out by the National Volcanic Surveillance Network, RNVV, created in 2009 after the eruptions of the Yaima and Chaitén volcanoes in 2008. RNVV allows authorities to have timely information for the management of volcanic emergencies and decision-making focused on the safety of the population. This includes the establishment of real-time surveillance of 45 volcanoes in national territory. At the RNVV, multiparametric monitoring is carried out depending on the risk level of each volcano. A network of stations with different types and quantities of instrument is deployed. This table shows the number of stations by type installed. Currently, we have a total of 335 stations. The acquisition of ground motion and infrasound parameters is done with airborne software. The RNVV mainly uses sensors and digitizers of the following brands: Gural, Reftec, Pantera, and Basalt. Data transmission is continuous from the monitoring stations, and the sampling rate is 100 samples per second. Raw data is stored in the MySQL database management system on Winston database. The size is approximately 28 megabytes per component per day. From the Winston web server, the team of professionals can read information with Swarm and many other software and process it with different tools made in MATLAB or Python. The data can be transformed into other formats with Python scripts, usually mini-SID format, at the request of users. In relation to the acquisition of deformation parameters, the data of GNSS stations is sent via FTP protocol. The files are stored in native format of Leica app and Trimble equipment. The data is transformed into RAINEX format and is processed with Trimble for the control, Gamut, and other software tools. The results are stored in MySQL database. We also have filmeter stations. The data is sent in real time, sampling every 10 seconds. All data is stored directly in MySQL database. Related to DOAS measurement, Novak software is used for data acquisition and processing the DOAS stations, measuring the flux of SO2 by day. Graphs are generated with the data stored in the MySQL database. Regarding the visual observation of volcanoes, there are online surveillance cameras, which send one image per minute or every 10 seconds, depending on the transmission capacities and the conditions of the volcano. Depending on the type of camera of stations, images are sent in low or high resolution. And we also have air cameras. Data sampling per minute, its format is a raw image in flexible file format with the information of thermal radiation. The files are transformed with Python routines for user viewing. Volcanic monitoring with magnetometers is a new discipline at the observatory and has been in development for a year. 7 stations have been installed to date. Processing is being carried out with magnetic field calculation models developed in Python. Raw data and results are stored in MySQL database. On this slide, we can see in the table a summary of the different disciplines, number of stations, daily storage consumption per station, and the annual consumption for all stations per discipline. High-resolution cameras consume the most storage space. Currently, annual storage consumption is around 8.5 terabytes. If we consider the data space already used from 2011 to today, the space consumption is around 98 terabytes. If we project to 2030 with an annual increase of 7% in the volume of data, we have that by 2030, the accumulated data volume will be 150 terabytes. It should be noted that is a variable and depends largely on the availability of the stations, which can be affected by weather conditions and the resource available for their operation. Where is the data stored? All systems and information generated by the RNVV are hosted in main OVDAS data center in Temuco City and a contingency data center in Santiago City, approximately 700 kilometers apart. Redundant hardware from Dell, Cisco, and Fortinet is used. Also, it uses software for server management and backups, like VMware vSphere and Vim Backup and Replication. The OVDAS systems teams makes call shift for any eventuality in the systems. All systems, networks, and applications are actively monitored with the tools Zabbix and Grafana, always seeking to ensure the operational continuity of the system and the protection of the information. What is done with all this data? All the information of the 45 monitored volcanoes is processed by data specialists at the OVDAS, working 24/7. Depending on the alert level of a volcano, seismology and geovolcanology teams are integrated into the working group. The surveillance room located within the observatory's facilities is equipped with electrical backup, redundant internet links, and satellite communication to ensure uninterrupted operation. What information is shown to the community? On the RNVV web portal, you can find information about the monitor volcanoes. For each volcano, it is possible to view online monitoring cameras, seismograms with data from previous data. Users can also view graphs with activities statistics for the past year for all instruments and review reports issued to date. In addition, there is an interactive ArcGIS viewer that shows the network of installed instruments and classified events. That's all. Thank you for your attention.
Thank you very much, Diego. The floor is now open for questions. You can feel free to use the chat or the Q&A feature, and I'll give you a couple minutes to type those out if you haven't already. It looks like we have a question from Jerry. Are the data from your observatory openly available to anyone?
Sorry, can you repeat?
Sorry, yes. Is the data from the observatory openly available to anyone?
Not for the moment, but in the future, we can consider the data for all users. Today, it's necessary to fill a form in the web for requesting data.
Thank you very much. From Dan Tari, what software are you using for earthquake analysis, like manual picking for an event?
Some software developed in the OVDAS, used in language Python, mainly works with OpSpy for picking or classify events.
Thank you. I am not seeing any other questions, but just as a reminder to everybody, you can feel free to write your questions whenever, and we will get to them at the end if we don't get to them now. Thank you, Diego, again for your wonderful presentation. We really appreciate you making the time. Thank you. Our next speaker is Tania Villasenor, who is a geologist and assistant professor at the Universidad de O'Higgins in Chile, and who specializes in sediment provenance studies. Her research focuses on understanding sediment generation and transfer processes from source to sink. Thank you so much for joining us, Tania, and without further ado, the floor is yours.
Thank you, Juliet. Do you see my screen?
Yes, I can see it.
Okay, so I'm gonna talk today about some available data sets to study sediment cascades or sediment or surface processes in general in Chile. And I wanna acknowledge the help of two colleagues, Raul Valenzuela and Claudia Mellado, who helped me to check some information that I'm gonna present. And I'm gonna present this data from a user perspective. So, because I usually look at this type of data when I'm working on my projects. So briefly, as a motivation, we're currently under climate change, and the temperature regime in the mountains is changing, and precipitation regime is also changing. That leads to changes in the processes of sediment generation, landslides occurrence, for instance, and how that sediment moves from the mountains all the way to the oceans. That's sediment cascades. And the type of data that is useful to look at these type of processes and the data sets that I'm going to talk about are meteorological data sets, hydrological data sets, and some online platforms. And all this data is freely available for everyone. And I'm going to show you how to access this type of data in Chile. So I'm going to start with meteorological data sets. And this is the website I'm showing here, a screenshot from the website of the Dirección Meteorológica de Chile, or the Meteorological Directorate in Chile. And they have a set of 129 meteorological stations, which are shown here in the map. And they record precipitation, temperature, wind velocity, and atmospheric pressure. And the resolution goes from minutes to hours, okay? And you can see here, this is another zoom to the map that shows the meteorological stations. Most of them are located on the central depression in Chile and towards the coast. And this is because most of these stations are meant to provide information for aviation purposes. So you see that there aren't many stations in the mountains, yeah? And here I'm sharing the link to this website. This is only in Spanish, so you have to understand a little bit of Spanish to move around the website. And what type of data can you access from here? You can download data at the minute resolution for 1 day. And this is the screenshot for that website. And you have to access the code of the station. So using the map that I shown in the previous slide, you look at the code, you put it here and the date you're interested in, and then you can access the data. You can also look at data for the last 28 hours. Again, you have to input the code of the station and the date you're interested in. And here the resolution of the data is by the hour, okay? And you get all the data set, the temperature, wind, pressure, and precipitation. And also you can access historical data, everything that is available for every station that they have in their system. And precipitation data, for example, the resolution is for every minute. So you can get very detailed information. And all this data comes in, I think it's comma-separated value format. But also, there's the Center for Climate and Resilience Research. This is a center that is hosted at the Universidad de Chile, and they have compiled meteorological data sets, specifically precipitation, starting early in the 20th century. And they have compiled data from over 800 stations for daily accumulated precipitation, which is shown here in blue and green, and for over 1,000 stations for monthly accumulated precipitation, okay? That it's shown also that it covers all these stations here in green as well. And this is the link to the website that leads you to that data set. So you download the data for all the stations that have data for this period of time. And also the same for temperature, but they have compiled data for over 200 stations for daily mean temperature, and also for some stations for daily mean, maximum, and minimum temperature as well, okay? But the data is available up to the year 2019, okay? And this is the link for that website as well. So instead of going to the other website that I just shown you before, in which you have downloaded data for every station individually, you can access this type of data in where everything is compiled, in case you want to look at the bigger picture. This center has also developed a gridded climate data set that is called CR2MET. And they include 2 products of daily precipitation and near surface maximum and minimum temperatures. And they have developed this for mid-20th century to 2024. The idea is they combine the observed data from the meteorological stations that are shown here with the dots, and also combine that with the ERA 5 data, and they have downscaling. So they developed this gridded climate data at this regular 2.05 degree latitude longitude grid, which is about 5 kilometers, which is a very good resolution for the country. And so here are the two links to the websites in which you can access this data. And this is good for if you want to look at long historical records at the country scale. And talking about hydrological data sets, they come from the Dirección General de Aguas, or the General Water Directorate in Chile. And they have divided Chile in 139 fluvial basins in the mountains, closed basin, and coastal basins. And along Chile, they have over 700 stream gauging stations, which are shown here in this map in yellow, in pink dots. And you can see most of them are concentrated here in central, south Chile. And they also have 76 sediment stations shown here in purple, and over 500 meteorological stations. And these are different from the stations of the Meteorological Directorate. And they have a broader distribution in Chile. So in many cases, the equipment or these stations have been installed since the early 20th century. And currently, this is data from January of this year, we have over 1,300 active stations recording data. So for the stream gauging stations, how to access this data? Well, they record discharge, water height, and water temperature. And the measurements in every station goes from every 15 to 30 minutes. It changes the station from station. And what happens is that the data is transmitted from the gauging stations to the website of the Water Directorate. You can access the data using this link. And I'm sharing the links here because these websites sometimes are hard to navigate. And it's recommended to use Google Chrome to access the data. So this is the Sistema Hidrométrico en Línea. So it's the online system that is recording the data. You can access a map to see which stations are active, and then you can download the data. What happens next is that this data that is received is revised by the professionals in the directorate, and then they archive the data, and that's kind of the definitive database that you can access using another website, another link, which is shown here. And this is the online statistical hydrological data sets, and you also access using that data using this link here. For the meteorological stations, you access this data using the online data set that is transmitted every hour to the directorate. Here is a screenshot of the how it looks, the distribution of the meteorological stations, and we see here that we have many in the mountains and the central depression, and also towards the coast. And what they record: precipitation, air temperature, and humidity. And the resolution, it goes from hours to daily values, mean, maximum, and mean meteorological data. Here's a screenshot of how the website looks like. So you select the stations that you're interested in, and you select the data you want to look at: precipitation, temperature, humidity. And this is also a stream gauging station, so you can also access using the same website, discharge, precipitation, water conductivity, etc. And then you select the dates you're interested in, and then you download the data in an Excel file format. And regarding the sediment stations, they record suspended solid concentration in milligrams per liter. And what they do is they have two methods of recording this data: the routine sampling, in which an observer, which is someone that usually lives nearby the station, takes daily samples using a bottle, and then that samples go to the water directorate and they process it and calculate the concentration of solids. And you can access this data using the archive data website. And also they do an integrated sampling, and that happens monthly using special samplers, and this data is only available through special requests using the website. And this is an image that shows from north to the left to south to the right, all these stations that have measured sediment concentration, and the colors represent how complete is the data set. So the warmer the color, the more complete it is. So we can see that it's not complete in every station. So that's because the sampling has been intermittent through time, and many stations started in the late, in 1985. That give us right now about 30 years or more of data in some stations. So that's good to study processes of sediment transport, for instance. And I'm gonna briefly talk about some online platforms that compile some of these data, and these are very user-friendly. You can look at the data and decide whether you want to download it or not. And this is the Explorador Climático or Climate Explorer. That's the link in which you can access precipitation, air temperature, and water discharge for many stations in Chile, also some data from South America and Argentina and other countries, and that's only for precipitation and temperature. There's also the VisMed, and this is only for precipitation and air temperature in Chile. And that's meant to be used to look at short-term events, because it gives you the chance to look at data over a range of 72 hours, no more than that. So it's a good visor in case you want to look at data during an event. There's also the CAMELS platform that means catchment attributes and meteorology for large sample studies, the Chile datasets, that integrates physical and hydrometeorological information for watersheds in Chile. And I'm gonna show you how it works. This is the website. So you pick a one of these dots that represents a stream gauging station, and that is at the exit of the watershed. And then for each watershed, you can look at discharge, runoff, precipitation goes next, and all the data that is available for each station, temperature, and evapotranspiration. So, and all this data, then you can download it here. You can download data and the database. Also, there's the RExplorer, which is to visualize and download atmospheric variables obtained from the ERA5 dataset. It's for Chile and South America, so it's also very user-friendly. You can select the date you're interested in, which variable, and then you decide whether you want to use the data or not. And last but not least, this is Portal Geomin, which belongs to the Geological Mining Service in Chile. And it's a catalog for geological and mining information. And for instance, here I have all the records of landslides, if we are interested in sediment cascades. And also you can load other data sets that they have available here, like for instance, well, this is assuming to the catalog of landslides. Then you can click on each of these points, and it takes you to the reports that describe the landslides, because usually these are related to precipitation events, for instance, and then you can compare the record with, for example, here, the geological map of Chile as well. So some concluding remarks. There's climatic, hydrologic, and geological data freely available. We have data from the early 20th century, but some websites are hard to navigate and find the data. But we have these online platforms that compile different data sets and then you can easily access and look at this data if you're interested in. And problems we have gaps in data because of intermittent measurements, sometimes equipment failure, encounter quality. And that's something that I didn't mention, but sometimes when for the discharge data, sometimes when it goes from the online record to the archived record, some data is missed because it doesn't meet the standards, the data standards. And sometimes some of the websites are not available. This is a screenshot that I took today of the water management website. So those are the things that happen sometimes. So thank you.
Thank you very much. We have a few minutes for questions if anyone wants to put a question in the chat or the Q&A feature. We have a question from Emily Brodsky. What do you see as necessary steps for improving this data service?
That's a good question. I think it will be necessary to have some sort of communication with these agencies that have the data that collect and have the data in their websites to make it more easily accessible. I think that's a challenge. Even scientists that live in Chile doesn't know necessarily how to access the data. And because, well, one thing that has happened is that these online platforms that the Center for Climate and Resilience Research Center has developed, it has been good. I mean, a good service for the community because they have compiled all the data, and they have made that communication to have that data transmitted from the Water Directorate or the Meteorological Surveys to their website, to their platform, so we can access the data from there, but it's not all the data that it's around. So probably some input from the community will be good in order for them to improve their access to the data.
Thank you. I'm not seeing any other questions at the moment, so I think we will move on to our next speaker. But again, if anyone has any questions that they think of later, please feel free to put them in the chat and we can address them at the end. So without any further ado, our next speaker is Juan Carlos Báez, who received his PhD in geodesy and is currently the head of geodesy at the National Seismological Center at the University of Chile. Without further ado, the floor is yours, and thank you so much for joining us.
Thank you, Juliet, for the kind invitation, and also thank you for the SZ4D community to show and share what we are doing at the National Seismological Center in Chile. First of all, I will present the information related to the seismic data, which was prepared by Felipe Leyton and Bruno Garcia. Felipe is the head of innovation and transference technology from the National Seismological Center. And so let me start showing our network. So the network is composed of broadbands, GNSS, and accelerometers. The distribution of the different equipment is showing in these three maps. So you can see we have a large network to the rapid characterization of earthquake. There is also the strong motion stations with 297 stations distributed along the country, and more than 128 GNSS stations also distributed around the country, including Easter Island, St. Felix, and Robinson Crusoe Island, and also one station in Antarctica. So This is the kind of instrument we are also using at this National Seismological Center, and any station is composed of a seismic sensor, and we call the multiparametric station. That station has the three components, and there are also some other stations separated with only one component. So the station is with including the three components. It also has a strong communication using satellite communication directly to our analysis center in Santiago. So related to the seismic data, I can say you can find all of the old instrumentation from the C network, composed of 54 stations at the network C, and then network C1, and also the CX from the north of Chile, from the IPOC project. So you can also see, yes, from the EarthScope, there is also all the information related to this kind of observation. As soon as we produce the observation from seismic sensor, that is published in an IRIS, so you can get all the information from every station from that site. Related to the strong motion database, the National Seismological Center started on 2012, so we have an increasing number of records for events of PGA major of 2% of G. So large part of the records, the distance from 70 to 200 kilometers, and it's registered from magnitude 4 to 5.5. And a few records from magnitude major than 7. So here you can see the distance of the different sensors depending of the different events, and about the data. So location of the accelerometers will show you that we have more information from north of the Chile area, and it's because of two phenomena. One is because we have a large amount of instrument at the north, and also because we have more earthquakes at the north of Chile. And of course, we have some areas with not a very spare network in Atacama, for example, which is also important, but there are not a lot of instruments on that region. So at the south, there are a low amount of events, and that's because of the distribution of the network also. You can see on the map, there are not a lot of instruments at the Patagonia, and also because it is not, we don't have a lot of earthquake on that region. So the number of records over time, as a function of time, you can see there's an increasement here. This is 1,000 of events. It's increasing over the years. And there are also some significant events. Iquique, Illapel, Valparaíso. And also interesting, this one in Huasco, which has a large amount of earthquakes registered. If you want to access the database, you can go to this site, AVGDB, from CSN, and you can see here there is a list of events. You can also select by date or latitude, longitude, and these events also are in UTC. And for example, this one corresponding to this one here. So you can search. Sorry, the web page is in Spanish because we are supported by the national authorities, so we have to produce a web page in Spanish. If you want to download the record, yeah, so you can select the record and you can choose to download the binary data and also the map, or you can also download from plain text. Here, data for a particular event. So we choose it here, the east-west component, and the star represent the hypocenter of the event, and you can see that all the signals are scaled by this factor here. So related to the seismic and strong motion information, I can comment on the end that the strong motion database enables online access to the Chilean earthquakes data, include more than 3,800 events. Most of the records are between 70 to 200 kilometers of distance and magnitude 4 to 5.5. And all data you can access and download freely available. So now moving to the next observation, I would like to show you the GNSS observations, what we use to develop application for earthquake studies. And let me show you using these three earthquakes from left to the right. It's Iquique, 2014. It's Illapel, 2015. Valparaiso, 2017. These three earthquakes is 8.2, 8.4, and 6.9 in magnitude. So what we can see here is the real-time observation of the GNSS stations and also the information coming from the strong motions. So what we can see here is two observations. First is comparing the GNSS observations here and the strong motion in one component. So we cannot see the P wave arriving to the station. For example, for Illapel earthquake, the station Fray Jorge and Pedregal, but we can see also the P and S wave arriving to the strong motion. And also what we can see here is in the GNSS observation, we can recover the displacement directly from the observation in this case, let's say 2 minutes. In 2 minutes, we have the complete signal of the displacement. Some similar to Iquique earthquake. So if we are, let's say, in 150 seconds, we can get the complete signal in these two kind of observations. So that's the observation we use at the National Seismological Center related with GNSS. We installed in more than 130 stations. We use the product from one of the companies, which is called RTX service, to do the real-time positioning. And 100 station has these capabilities, and other 50 receiver has only the conventional information, which we stream using the cascade. Also, we use the information from the Argentinian station. And also, we have deployed some stations close to Santiago to observe the San Ramon fault system. So here in this map, you can see the blue are the station from CSN. In green, it's from research project, and in red here from Argentina. So all the data is published in a FTP server. You can access using these two links here. The observation upload here using the most used, let's say, acronyms to download or store the GNSS observation, that is year and day of the year. Then, for example, if you look inside of the observation from last Sunday, there are a list of observations. Observations are stored in Rinex, conference Rinex, and all the metadata it's checked before to conversion any observation. So the metadata is corrected in case there are wrong information inside. The sampling rate for most of the observation is 1 Hertz, but also we have 15 seconds depending on the station. And also we are publishing observation in 1 Hertz for different events. In the case, for example, Maule, Iquique, and other earthquakes in a separate place. So in terms of result, we have, this is a case for the Illapel earthquake. This is station Fray Jorge. And here we have the 1 Hertz observation from the station, and we can recover from here the previous trend and the complete signal of the earthquake, and also the peak ground. So all of these results also are published for the use of the community. In terms of analysis of long period of data, let's say years, we also do the analysis of the different detrending the observations and produce signal for Chile, for Argentina, and also for complete South America, because the amount of station of free open station are increasing by the years. So we use or take advantage of all of this information to analysis this observation and produce, for example, these locking maps showing here, for example, the let's say the largest earthquakes from past 20 years up to now. And also we identify the seismic gap in different areas of Chile, and it's in coincidence with areas with a high logging degree. And we also increase the observations, trying to use old observations, for example, using the not permanent seismological observation, which is freely available, and using the GNSS observation from the different stations. In blue here, CSN, in yellow, research project, and in red here is from the volcanologic observatory. We also start to observe campaign stations from different projects, from Central Andes GNSS project, from French group from IPGP and also from the German group in Potsdam. And we are applying for a project with Sergio Ruiz and Moreno and several other collaborators to analyze all of the observations and also include all observations or all geodetic information from the old triangulation network and labeling network, and also using the paper seismograph and also paper myograms for different relevant events. So as a final comment, so we have deployed an extensive GNSS network for the rapid characterization of earthquake. Our system generates high quality real-time data, which is stored and made freely available for use by the entire technical and scientific community around the world. From our research work, we focus on densifying our network in areas of high interest for studying the seismic cycle and earthquakes, enable us to observe transient, slow-slip event, faults, and earthquakes in greater detail. We are working now to digitize historical geodetic and seismological records to make them publicly accessible and analyze them using modern techniques. So it's all I want to show you. Thank you very much. I'm happy to receive any question if I can answer.
Thank you. If you have any questions for Juan Carlos, please put them in the chat or the Q&A feature. I'll give everyone a couple minutes. Okay, I'm not seeing any questions, so I think we'll move on to our next speaker. If you think of a question in the time being, please feel free to put it in the chat and we'll get to it after. So without further ado, our next speaker is Catalina Fortuño, who received her master's in earthquake engineering with disaster management at UCL and engineering sciences at Pontificia Universidad Católica de Chile, with experience in deterministic and probabilistic seismic hazard modeling. Catalina currently holds the position of Chief Technology Officer at iTrend. Thank you so much for joining us, and without further ado, the floor is yours.
Thanks, Juliet, and thank you for inviting us here to this workshop. Today, we are going to present a project that we have that is called Data for Resilience, which looks for making available all the data that we in Chile are developing around risk management and resilience for doing research and development, specifically in different areas of studies. Specifically, before explaining you about this project, I would like to briefly introduce what the Institute is and what we do. We are a non-for-profit organization that has public funds. We have a mandate to be a strategic partner of the state in disaster resilience through developing technology and applications based on data and models that allow decision makers make informed technical decisions in different stages of the risk cycle. And also promoting the collaboration between different sectors, the academic sector, the industry, the public sector as well. So we are focused on the specific needs that we have as a society in Chile and how all the knowledge that we have can help reducing those gaps in resilience and somehow building new solutions for those needs. So one of the problems that we are addressing comes from the very beginning of this institution. Some years ago, in 2016, there was a group of people that developed a national strategy for building a better country in terms of the disaster resilience. And in this national strategy, they considered pushing for different tasks for tackling problems as building better hazard maps, for example, warning systems, innovation in policies, technology and materials, and different kind of in different type of areas. And they all agreed that for building and developing and deploying those tasks, it was very important to have data and information. The data and information that we have for building new solutions and for building different or opening different areas of research, specifically in Chile. So the problem that they acknowledged at that time was that there was a limited access, high fragmentation, inconsistency, and lack of systematization in data in Chile for studying, analyzing, and developing new solutions. So we, as a public fund institution, are tackling this problem by enabling a digital infrastructure at the service of all this ecosystem for helping making this data available for all, promoting some standardization in metadata and data, of course, and promoting also collaboration between all the different actors that are working on these topics. Since 2019, where we started as an institution, we have been working in this specific project. First, in 2021, we launched a pilot program that was called Plataforma de Datos. And in this very beginning, we spent some time learning from the users and understanding what were the experiences that they need to be solved by this product, and understand also what kind of data sets they need to have in place so they could make more advance in these topics. Also, we learned that for making all these data and information available, we not only needed to build one system, web system product, but also needed to build a whole digital infrastructure. So in 2022, we started to design a software infrastructure architecture where all these kind of solutions around data and models could live in the future. And also we started working very close to SENAPRED, specifically, which is the FEMA here in Chile, kind of the FEMA, specifically around data about the warning system unit in SENAPRED. So we started to build more around this concept of making data available and not also about availability, but also about visualization and about giving tools for understand the data, work with the data, and also make specific tools for decision makings in different levels, in different phases of the cycle of the disaster risk management cycle as well. So now, very soon in November, we are planning to launch a new version of this, the specific project about open data for resilience, which is called now Data for Resilience, or Datos para la Resiliencia in Spanish. And this project is based on a particular software that it was developed by by Harvard University. And this the database project that we used for building this software is specialized in management of data catalogs. And we are planning to build from this project that is supported worldwide for addressing the particular needs of our users here in Chile and the users that maybe are not here in Chile, but they are willing to look for data that we are building here and different research that is being developed here in Chile. So this platform that is coming soon here in this address and this URL is an open access platform. So it allows you to find, obtain, and share and preserve quality data sets for research and development. It has a kind of evolving catalog composed of different areas of datasets such as geospatial, demographic, meteorological, social, records of past events, etc. And we promote data standardization through defining a specific standardization for metadata. And also we promote the standards of citation so everybody can access and refer to the proper author of the data. So if I have some time before finished, I would like to, I don't know if you're looking my screen now. Let me see. Okay, are you looking at the Datos para Resiliencia website right now? Sorry.
Yes, we're seeing it.
Thank you. So very quickly, I want to navigate this website. I said that it's coming soon. We are still fixing some details for the launching, but is almost done. So I wanted to navigate very quickly in this website, which has some data sets already in place. We have to fix some details about the translation. That's why it's mixed between English and Spanish. It has both languages. It's going to have both in place, but now it's kind of mixed. So sorry about that. And we have here different data sets that you can explore. And also we have these called feature collections, which you can explore for specific topics. They are like labels in the data sets. So for example, if you can look here for information about landslides, specifically, you can have different information of data sets, or if you want to look at something about exposure, for example, we have some specific data sets from different authors and institutions, and specifically, if you can get there in this in one of the data sets, you have the information about the author, the DOI of the data set, a little description about the data set that you are looking at, of course, the related publication of the data sets, if this is the case. You can have the citation in different formats also, if you would like, and the author allows us, of course. You can contact the author of the data set, so the group of authors as well. And you can have the data set downloaded with different formats if it is available. You can see a specific metadata of the data sets as well. The terms and condition, which is overly in most of cases right now is open. And also you can see different versions of the data set if it's the case. This is very important because the data and the information evolves in time. So it is very important to have these traces of how this information is evolving. And you can get back to another version, or maybe update the work that you're doing with new versions of the data. For example, in some cases, you can see as well the information in a brief map. It's not like a GIS or ArcGIS or similar software, but it allows you to see what is the coverage of the data set if there is some territory format or shapefile in the data set. So I just wanted to show you a little bit about it. You are invited to explore it. We are soon going to launch this this website, probably in a special seminar or something that we are going to announce soon. We invite you all to explore as well, and to contribute to this project by sharing your data. We are trying to build this community of expert specialists that are working on risk, disaster management and resilience. And we understand that it's very important for the evolving of knowledge and the application of this field to have all these ways of sharing information and data and knowledge, and also to have some of this information in a standardized or a kind of a standardized way that makes easier for everybody to work and keep working and keep building knowledge around this. So you are all invited to navigate this platform and also to share your data. You can contact us through that email, and hopefully if you contact us, maybe we can also add you to our newsletter and send you information about this coming soon new website. Thank you so much.
Thank you. We already have a question in the chat from Emily Brodsky. How does this effort interact with the other Chilean databases we just heard about?
Thank you. Thank you for the question. We have a lot of work going on with different public agencies. We have like this collaboration, I don't know how to say in English, but like collaboration contracts with different public institutions where we share data and also help them to make some data that is not easily findable, available for more people, but adding a little bit of work in the standardization of the metadata, etc., and curating a little bit of that. We are also planning to make this effort more visible, so we can help the ones that have data that is not public available yet to make it available through this place instead of investing more money to making specifically visualizations tools, for example. But we are working with a lot of institutions for not duplicating efforts. The point is that, well, I think Tania said about this, told a little bit about this. Some of the data websites that we have in place here in Chile are not available all the time. Some of them are very not so easy to understand at the beginning. So we are focused on that user experience as well, trying to make it accessible for more people.
Thank you so much. We have a question in the Q&A section. This is for Juan Carlos that I missed before from Jerry Carter. So Jerry asks, have you considered offering FDSN web services for your seismic data?
For the new seismic data or for the old seismic data? For both one, for the new seismic data, it's digital and you can find and download from the IRIS site or AirScope if you want. For the old seismic record, we need to convert first to digital. So we are working on that before sharing.
Great, thank you. I will leave a couple more minutes. If anyone has any more questions, please put them in the chat or the Q&A for any one of our panelists. But I will take a moment just to give a heads up about our next activity that will be in about 15 minutes. So that's going to be our first discussion session, and it's going to be on archiving challenges. The link is different because it is a Zoom meeting as opposed to a Zoom webinar, so we can all discuss face-to-face. So I am putting that link in the chat here so that you all have it. It is also on your confirmation email that you got, as well as on the calendar invitation for the next activity. So please use that link to join the next discussion session. I'm not seeing any more questions for our panelists. So without further ado, let's give another virtual round of applause for our panelists. Thank you so much for joining. We really appreciated you taking the time. Oh, I think someone might have a question for Catalina. From Alvaro, is Senapred involved in the data platform?
Thank you, Juliet. Senapred is not involved in the development of the data platform, but he is one of the institutions that has give some data from the very beginning. So they are very engaged with the project, but it's not specifically a work with Senapred. Thank you.
Thank you. Okay. Thank you everyone for joining. I know we're a little bit over time, and I hope to see you all in about 15 minutes for that discussion session. Thank you all, and have a great rest of your day.
Thank you.
Thanks.
Thank you.